Hey guys, I'm Chris and welcome to this another math video on the Chris Maths Academy YouTube channel. In this video, we'll be looking at some fraction questions, all of which were retrieved from some of the most recent CSEC Math Past Paper 2 examination. But before we get into that guys, don't forget to hit that subscribe button if you haven't yet done it. Give this video a thumbs up, that really goes a far way in supporting the channel. And of course, you want to hit that notification bell, that way you can keep up to date with the new content that we'll be posting on this channel. In the same breath guys, this is really the beginning of a series of videos to come. So this week we'll be focusing on fraction, working some fraction questions. Next week we'll be focusing on some questions from another topic. Maybe you guys can let me know in the comment section which topic you desire those videos or that video to be focused on, so you can let me know in the comment section below. So let's get right into it guys. So we're looking at the question that was given on the January 2011 paper, and of course we'll go right up to some of the most recent questions at the time of creating this video, which were the ones that were given on the June and January 2022 paper, but we're working from old to the most recent, right? So the first thing that I'll do with this question is to rewrite this question, right? So instead of using a fraction bar here, I'm going to rewrite this using the division symbol. So I'll have 2 and 4 nines using the division symbol here, divided by 4 and 2/3, right? The fraction bar actually means the same thing as the division symbol here. So we can definitely do that. We didn't break any rule there. Minus, we have 3/7. Now the next thing I'll do is to convert the mixed fractions to improper fractions. And in converting these mixed fraction to improper fraction, we'll have 2 times 9, 18, plus 4, that's 22, divided by 9, have the division sign here. 4 times 3 is 12, plus 2, that's 14, divided by 3, minus 3/7, right? And you're probably wondering why I keep saying 14 divided by 3 and not 14 over 3. That's really the correct way of saying it. 14 divided by 3, because that's really what is taking place. So I'm just trying to use the appropriate language here. Next up, we're going to observe the order of operation here. And according to the order of operation, we must divide before we can subtract. So we're going to focus on this section first. And I'm going to continue on this side. So I have 22 divided by 9 here. And we'll have this in bracket. And remember guys, how we divide, we keep the first fraction, we change the sign to multiplication and reciprocate the second fraction, or what we can say, flip the second fraction, right? So bring the 3 to the top, the 14 down to the bottom, right? And that's pretty much how we treat with this section here. I'm just going to carry the minus 3/7 here, just the same. Now what can we do here? We can simplify somewhat, right? So we can say 3 into itself goes 1 time, 3 into 9 goes 3 times, 2 into 22 goes 11 times, 2 into 14 goes 7 times. After which we could proceed with multiplying across. Thus we'll be left with 11 times 1 is 11, 3 times 7 is 21. We still have this minus 3/7 here. Now, whenever we're subtracting fractions, it is required of us to have the denominators being the same before we can proceed with the subtraction process. So an easy way to do this, guys, all I need is the denominators to be the same. So I can apply the concept of equivalent fractions here. So I could ask myself, what could I multiply 7 by to get 21? There you go. That's 3. So I can multiply 7 by 3 to get 21. And to get an equivalent fraction such that 21 will be in the denominator here, Not only do we have to multiply the denominator by 3, but we have to multiply the numerator by 3 as well. And let's see how this will work out for us. We'll have 11 divided by 21 minus 3 times 3, that's 9, divided by 7 times 3, that's 21. And of course, we have common denominators here, which is what we want, guys, when we're adding or subtracting fractions. So 9 from 11, that's 2. So we're left with 2 divided by 21, which is our answer right here. Now we're looking at the question that was given on the January 2014 paper. And of course, guys, before I commence with this question here, if you're not completely clear with how to manipulate fractions using the 4 basic operations, I'll have some videos in the description section below where I went through the concept in a more detailed manner, so that will bring you up to speed with this video. So just in case you're not following and you're wondering how I do some of the things that I'm doing, you can check those videos out, and I'm sure they'll help you to make sense of what we're doing in this video. Of course, according to the order of operation, we have to work the brackets first, and that's exactly what I'll do here. So simultaneously, I'm going to focus on both brackets, right? So I want to convert the mixed fraction here to improper fraction. It always helps to get that done, guys. You don't have to, but I suggest you do. In my mind, somehow it makes things easier to look at that way. So we have 1 times 4. That's 4 plus 3, that's 7. So that's 7 quarters. Right, minus 1/8 in bracket. Let's see what we can do with this one here. So we divide in here, and remember how we divide, guys. We keep the first fraction. So that's 5, 6. Change the sign to multiplication, and we reciprocate the second fraction, right? Which means we simply flip it. So we bring the 3 to the top, bring the 2 to the bottom. Now let's see what we can do here, guys. Now observing this side, right? Here we have 7 quarters minus 1/8. And as I would have mentioned in our previous example, before we can subtract or move on or progress with the subtraction process, we need both denominators to be the same. So I can ask myself, I don't have to use the LCM method here. I can ask myself, which number can I multiply 4 by to get 8? There you go, that's 2. So I can multiply the denominator by 2. And whatever I multiply the denominator by to get the common denominator, I have to multiply the numerator by that same number. That way, we can end up with an equivalent fraction. And so we can close the bracket here, plus. So we have 5 in the numerator here. 5, 6 times 3 divided by 2. And we can reduce a little bit here. We can say 3 into itself goes 1 time. 3 into 6 goes 2 times. So let's see where we go from here. We can then look at this side again. So it's 2 times 7, that's 14 divided by 8 minus 1/8. And that's exactly what we want, guys. Common denominators on this side. Plus, we can multiply across here. So it's 5 times 1, 5, divided by 2 times 2, that's 4. So this side is already simplified. And I'll just draw a straight line segment here, and we'll continue on this side. So let's see. Now that the denominators are the same here, we can carry out our subtraction here. So it's 1 from 14. That's 13 divided by 8 plus this 5 quarters here. And as I would have mentioned several times since the start of this video, once adding or subtracting, we need the denominators to be the same. Here we're adding 2 fractions, so we need both denominators to be the same before we can progress with the addition process, right? So I can ask myself again, which number can I multiply 4 by to get 8? There you go again, that's definitely 2. And again, if I multiply the denominator by 2, I have to do the same thing to the numerator. That way, I'll be getting an equivalent fraction for this 5/4 here. And let's see what we'll have now. So it's 13 divided by 8 plus 5 times 2, that's 10, divided by 4 times 2, that's 8. And we can go ahead, now that we have common denominators, we can add the numerators. So it's 13 plus 10, that's 23, divided by 8. Or we could write it as a mixed fraction. So 8 can go into 23 2 times, leaving a remainder of 7/8. So either one of these are acceptable, guys. You could leave it as an improper fraction, but if you wish to write it as a mixed fraction, that's not a problem either. Now we're looking at the question that was given on the June 2015 paper. And here we go. So again, guys, I'm going to convert all my mixed fractions to improper fractions here. So all three I'll be converting to improper fractions. Starting with this one, so 2 times 5, that's 10 plus 2, that's 12/5 minus 1 times 3, that's 3 plus 1, that's 4/3, plus 3 times 2, that's 6, plus 1, that's 7 divided by 2. And what I'll do here, several ways how I could probably get this done, but I'll use the LCM method here, probably the simplest of all the methods, I would believe, right? So the LCM, which means the lowest common multiple for all three denominators, which simply refers to the lowest number that 5, 3, and 2 can go into without leaving a remainder. That number would definitely be 30. Following that step, we're now going to find out how many times can each denominator go into this 30 here, which is the LCM, and the amount of times that each denominator go into 30, the value that represent that amount of times, we'll use that value to multiply the corresponding numerator for that denominator. So let's see what I'm talking about here. So 5 into 30 goes 6 times. So I'm going to use that 6 to multiply the corresponding numerator for the 5. 3 into 30 goes 10 times. So I'm going to use that 10 to multiply the corresponding numerator for the 3. 2 into 30 goes 15 times. So I'm going to use that 15 to multiply the corresponding numerator for the 2 right there. Next up, we're going to evaluate these and see what we'll have here. So it's 6 times 12, that's 72, minus 10 times 4, that's 40, plus 7 times 15, that's 105. So 72 minus 40, I believe that's 32. 32 plus 105. See my 137 divided by 30. So you bring back the LCM here. So that's pretty much the solution right here, guys. What we could do is we could always write this as a mixed fraction if we wish to. So I believe this would be 4. So 30 into this goes 4 times. 4 times 30 is 120. 120 from 137 will leave us with 17 out of 30 right there. So we could leave our answer as an improper fraction, or we could write it as a mixed fraction like this one. Now we're looking at the fraction question that was given on the June 2016 paper. So using a calculator or otherwise, they want us to calculate all of this here. And what I normally tell my students, once you have a fraction-based type of question that has fractional numbers in both the numerator and denominator, it always helps to separate the numerator from the denominator. So I'm going to call the numerator top since it's shorter and easier to spell. So, and I'm going to write out what's in the top. So it's 3 and 3/8 minus 2 and a quarter. That's easier to look at, right? And I'm just going to focus on this for now. And as always, I'm going to convert the mixed fractions to improper fractions. So it's 3 times 8, that's 24, plus 3, that's 27, divided by 8, minus 2 times 4, that's 8, plus 1, that's 9/4. And again, guys, once we're subtracting fractions, we need the denominators to be the same. So I'm going to ask myself, what could I possibly multiply 4 by to get 8? There you go. That's 2. And again, once I multiply the denominator by a number, I have to multiply the numerator by the same number to ensure that I'll end up with an equivalent fraction. So let's see what I'll end up with, guys. So I have 27 divided by 8 minus 9 times 2, that's 18, divided by 8. Now that we have common denominators, we can progress by subtracting the numerators. So it's 18 from 27, that's 9/8. So we'll have the common denominator right there. And for the bottom, let's see what we have. So I refer to the denominator as the bottom. So we have 1/2. And the most that we can do with this 1/2 here is to convert this to a mixed fraction, which is 1 times 2, 2 plus 1, 3/2. Right? That's the most that we can do with that. Now, of course, we're not through, guys. So what we'll do next, so we would have simplified the top. So in theory, what we'll have here is 9/8 with the fraction bar sign here and 3/2 there, right? Now, another way how we could write all of this, instead of writing this using the fraction bar, I'm going to write it like this instead. So it's 9/8. And instead of using the fraction bar, I'm going to use a division sign instead. 3/2 divided by 3/2. And remember how we divide, guys. So we keep the first fraction, change the sign to multiplication, and flip the second fraction. So we'll bring the 2 to the top and bring down the 3 to the bottom. And let's see what we can do from here. So it's 3 into itself goes 1, 3 into 9 goes 3, 2 into itself goes 1, 2 into 8 goes 4 times, which will leaves us with 3 times 1, that's 3, divided by 4 times 1, 4. And this would definitely be our solution right there. Now we're looking at the question that was given on the January 2017 paper. So we have 3/2 times 1 and 2/3, all divided by 4 and 1/5. So again, guys, we're going to separate the top from the bottom. And of course, guys, it helps to, we would have done enough example, you probably catch on to how to maneuver your way around these questions. So you could pause the video, attempt some of these questions, then resume the video and watch and see if you would have followed all the correct steps. All right. So in the top, we have 3.5 times 1 and 2/3. And what I'm going to do here, just like previous times, I'm going to convert the mixed fractions to improper fractions. And in doing so, I'll have 3 times 2, 6, plus 1, 7/2, times 1 times 3, 3 plus 2, 5/3. And there's nothing here to cancel, that can be cancelled out. So I'll multiply across. So I'll multiply the numerators together. 7 times 5, that's 35. The denominators together, 2 times 3, that's 6. And that's pretty much the top. Now I'll look at the bottom, what we have in the denominator. So I have 4 and 1/5. And the most I can do with this, guys, is to convert it to an improper fraction. So 4 times 5, that's 20, plus 1, that's 21 divided by 5. So that's what I got for the top, and this is what I got for the bottom. So I'm going to continue on this side. So what we're going to do now, guys, as you would have seen in the previous example, we'll have the top being divided by the bottom. So the result from the top, 35 divided by 6, we'll have the division sign here instead of a fraction bar. And we'll have this fraction here, 21 divided by 5, right? And remember how we divide when we're treating with fraction, guys. Dividing by a number is the same thing as multiplying by its reciprocal. So I'll bring the 5 to the top and 21 to the bottom. And of course, guys, there's some reduction that can be done here. So I can say 7 into 35 goes 5 times. 7 into 21 goes 3 times. Thus, we can multiply straight across. The numerators are what is left of it together. So 5 times 5, that's 25, divided by 6 times 3, which is 18. And this right here would definitely be our answer. Or we could have written it as a mixed fraction as 1 and 7 out of 18. So this is another form in which we could have written the answer as well. Now we're looking at the question that was given on the June 2017 paper. And of course, guys, again, we have to observe the order of operation. So we'll start with the brackets first. And what I'll do here is to convert the mixed fractions in this bracket here to improper fraction. So I'll end up with 4 times 3, that's 12, plus 1, that's 13, divided by 3. 1 times 5, that's 5, plus 2, that's 7, divided by 5. Close bracket, and I still have this divide by 4/15 here. And because this falls within the bracket, we have to do this part first. So here we have 13 divided by 3 minus 7/15. And you're probably wondering, now as I said before or in previous examples, we don't always have to use the LCM method to get the denominators to be the same. For example, using the concept of equivalent fractions here, what I could do is to use this denominator here to multiply both the numerator and the denominator of the other fraction, and use this denominator now to multiply both the denominator and numerator for the opposite fraction. Now, if you observe carefully, we'll have the same thing in both denominators. 5 times 3 on this side, 5 times 3 on that side, which means we'll end up with common denominators at the end of evaluating both denominators right here. So I'll just keep these in brackets. Still have this divide by 4/15 here. And let's see what we'll get at the end of this. So it's 5 times 13, that's 65. Divided by 5 times 3, that's 15. Minus 7 times 3, that's 21. Divided by 5 times 3, that's 15. Now we have common denominators here. So we can proceed with the subtraction. Still have this 4/15 out here. And we'll continue on this side. So in continuing, let's see what we'll end up with here. So it's 65 minus 21. We can do the subtraction of the numerators here since the denominators are the same. 21 from 65, that's 44 divided by 15. We'll have this division sign here and 4/15. And it's important to note, guys, that when dividing fractions, we keep the first fraction change the sign to multiplication here, and flip the second fraction. So we bring the 15 to the top, the 4 to the bottom. After which we can say 15 into itself goes one time, 15 into itself again goes one time, 4 into itself goes one time, 4 into 44 goes 11 times. Thus we're left with 11 times 1, which is 11. 1 times 1 is 1, so it's 11 divided by 1 is just 11. So this would definitely be our answer. Now we're looking at the question that was given on the January 2018 paper. And by now, guys, you would have guessed it. Of course, we'll convert the mixed fractions, the improper fractions, right? I'll suggest you do that once it's possible. So let's see what we'll get. So it's 5 times 2, 10, plus 1, 11, divided by 2. I have the division sign here. 3 times 3 is 9, plus 2, that's 11, divided by 3. Plus 1 times 5 is 5, plus 4, that's 9, divided by 5. And of course, guys, we have to observe the order of operation here. So we have to divide before we can proceed with the addition process here. And in dividing fraction, guys, recall we keep the first fraction, change the sign to multiplication, and flip the second fraction. So we'll bring the 3 to the top and the 11 to the bottom. I keep this in bracket for now. And we have plus 9/5 here. Now we can definitely simplify this one. So we can say 11 into itself goes one time, 11 into itself again goes one time, which means, and let us continue on this side. So we'll be left with 1 times 3, that's 3, divided by 2 times 1, that's 2, plus 9/5. And though we don't have to use the LCM method here, I'll just use the LCM method for one, since we would have been using the concept of equivalent fraction moreover. So let me demonstrate the LCM method for this one. So the LCM for 2 and 5 would be 10. So that's the smallest number that both 2 and 5 can go into without leaving a remainder. Now 2 going to 10 5 times. We use that 5 to multiply the corresponding numerator for the 2. 5 into 10 goes 2 times. And we'll use that 2 to multiply the corresponding numerator for the 5. Thus, we're left with 5 times 3, that's 15, plus 9 times 2, that's 18. 15 plus 18, that looks like 33, divided by the LCM, which is 10, and this is our answer. Or we could have written it as a mixed fraction as 3 and 3/10. So that's another way how we could have written our answer as well. Now we're looking at the question that was given on the June 2019 paper. And again, I'll separate the top from the bottom. So in the top, we have 2 and a quarter minus 1 and 3/5. And by now, guys, you know the next move. I'll convert the mixed fractions to improper fractions. So I'll have 2 times 4, that's 8, plus 1, that's 9 quarters, minus 1 times 5, that's 5, plus 3, that's 8/5. And I won't use the LCM method this time around. I'm just going to use the 5 on this side to multiply both the numerator and denominator here, and this 4 on this side to multiply both the numerator and denominator here. And again, the main idea behind doing that is to ensure that we end up with common denominators, which will have, as you can see here, we have the same thing in both denominators, 5 times 4 on this side, 5 times 4 on the other side. So we have 5 times 9 there, that is 45, divided by 5 times 4, 20, minus 8 times 4, that's 32, divided by 5 times 4, that's 20. And now that the denominators are the same, we can proceed with subtracting the numerators. So 32 from 45, that will leave us with 13 divided by 20. And that's what we get for the top. Let us look at the bottom here. Well, we can't do much with the bottom, right? The bottom is just 3. So what we'll have is the top 13 divided by 20, and we'll divide the top by the bottom, which is 3. And another way how we can actually write this 3, we could write this as a fraction as 3 divided by 1. Same thing as 3, but it's easier to work with this way. And recall how we divide fraction, guys. We keep the first fraction, so the 13 divided by 20. Change the sign to multiplication and flip the second fraction. So we'll bring the 1 to the top, bring the 3 to the bottom, and we can multiply straight across because we can't reduce anything here. So it's 13 times 1, that's 13, divided by 20 times 3, that's 60. And this is our solution here. Now we're looking at the question that was given on the January 2019 paper. And again, I'm going to separate the top from the bottom. In the top, we have half times 3/5. Pretty easy fraction to work with. So it's 1 times 3, that's 3. 2 times 5, that's 10. And that's pretty much the top. The bottom we have here is 3/2. And by now you guys know we'll convert this mixed fraction to an improper fraction. So 3 times 2, 6 plus 1, that's 7/2. And let's see how we'll treat with this now. So we'll have the top 3/10 divided by the bottom, which is 7/2. And again, guys, would have done this several times before. So in dividing fractions, we keep first fraction, change the sign to multiplication, and flip the second fraction. So let's see what we'll end up with here. So we can reduce this a little bit. So 2 into itself goes 1, 2 into 10 goes 5 times. So we'll be left with 3 times 1, that's 3. 5 times 7, that's 35. And that's our answer right there. Now we're looking at the question that was given on the January 2020 paper. And of course, guys, we'll convert all the mixed fractions to improper fractions. I only have 2 mixed fractions here. So we'll have 4 times 5, that's 20 plus 1, that's 21 divided by 5 times, I'll just bring back this 1/3 here, that's not a mixed fraction, minus 1 times 4, that's 4 plus 1, 5 fourths. And of course, guys, observing the order of operation, we'll have to multiply first before we can subtract. So let's see what we'll end up with. We can reduce this a little bit. So we can say 3 into itself goes 1. 3 into 21 goes 7 times, which will leave us with 7 times 1, 7, divided by 5 times 1, 5, minus 5/4. And I'll just demonstrate the LCM method here. I was stuck between 2 minds. The equivalent fraction method seem a lot easier, but let's do the LCM method here. So it's 5 into 20 goes 4 times. 4 into 20 goes 5 times. Next we'll have 4 times 7, I believe that's 28, minus 5 times 5, that's 25. So we'll be left with 25 from 28 will leave us with 3, divided by the LCM, which is 20. So there we go. That's our answer right there. Now we're looking at the question that was given on the January 2021 paper, and we'll convert the mixed fractions to improper fractions. Thus we'll end up with 1 times 7, 7 plus 4, that's 11, divided by 7 plus 2/3, minus 1 times 6 is 6 plus 5, that's 11, divided by 6. And I'll use the LCM method here. The lowest common multiple for 7, 3, and 6, that would be 42. So we'll have 7 into 42 goes 6 times. 3 into 42 goes 14 times. 6 into 42 goes 7 times. So let's see what we'll end up with. So it's 6 times 11, that's 66. Plus 2 times 14, that's 28. Minus 7 times 11, that's 77. Is equal to 17 divided by 42. And this will definitely be our answer right here. And now looking at the question that was given on the June 2021 paper. And again, we'll convert all the mix to improper fractions. So let's see what we'll have here. 1 times 7 is 7 plus 4. That's 11 divided by 7. Have the division sign here. 2/3 minus 1 times 7 is 7 plus 5, 12 divided by 7. And what we'll do here, guys, we'll observe the order of operations. So we'll have to divide first before we can subtract. And recall, when we're dividing, we keep the first fraction, change the sign to multiplication, and reciprocate the second fraction. So we'll bring the 3 to the top, 2 to the bottom, close bracket, minus 12/7 here. And we can't reduce anything here, so we'll be left with 33 divided by 14 minus 12/7. And I'll continue on this side here. So I have 33 divided by 14 minus 12 divided by 7. And I won't use the LCM for this one. I'll just use the concept of equivalent fraction here. So I'll ask myself, what number can I multiply 7 by to get 14? That's 2. And I'll multiply the numerator by the same number. Just to ensure I'll end up with an equivalent fraction. So I'll have 33 divided by 14 minus 12 times 2, that's 24. Divided by 7 times 2, that's 14. And 24 from 33, that's 9. And we keep the common denominator here, which is 14. So 9 out of 14 would be our answer right there. And now we're looking at our final question, guys. The question that was given on the June 2022 paper, and the most recent paper at the time this video was actually created. Now, we have to observe the order of operations here, and we are required to divide before we can add. And that's how we are going to go about this one here. So we have 7/8 plus, and we're going to treat with what's inside of this section first because we have to divide first. So I'll keep the first fraction. That's how we divide. Change the sign to multiplication. Flip the second fraction. So I bring the 9 to the top, the 2 to the bottom, close bracket there. I look at this, and of course we can reduce a little bit. So I can say 3 into 9 goes 3 times. 3 into 6 goes 2 times. So I'm left with 7/8 here, plus 1 times 3, that's 3, divided by 2 times 2, that's 4. And again, guys, using the concept of equivalent fractions here, which number can I multiply 4 by to get 8? That's definitely 2. And I multiply the numerator by the same number. So I'll end up with an equivalent fraction. I'll continue on this side. So I'll have 7/8 plus 3 times 2, that's 6. 4 times 2, that's 8. Let's see what we'll end up with. So we can proceed and add the numerators together since we have common denominators here. 7 plus 6, that's 13 divided by 8. So that's our answer. Or we could write it as a mixed fraction as 1 and 5/8. So this is another form in which we could have represented our answer. So that brings us to the end of this one, guys. I hope you found this video very helpful. If you actually found it very helpful, what are you waiting for? Hit that subscribe button, give us a thumbs up, and let me know in the comment section below which topic would you like for us to look at next. Thanks for sticking with me to the end of this one, guys. I'm looking forward to see you in our next video. I'm Chris from the Chris Maths Academy. Until next time, blessings and peace.